Hello, welcome to another tutorial. In this video, we'll be going over how to use the SDKs in C#. So here on my Windows computer, I'm going to open up the C# folder. And right here, the solution file, you're just going to go ahead and open that using Visual Studio. Once you have this opened, you can scroll through. And there is a lot of sample code here, and we'll also have some demos. So the most important thing here is at the top of this file, you have this robot IP. So this is the IP address of the robot, which you can find on your teach pendant. You can go into settings, system, network, if config, and you can see here it's 192.168.181.170 for me. And that's what I have here. So just make sure this IP address here matches your robot's IP address. So here, let's go through a few demos. At the bottom of this file, you have this main function here, void main. And inside here, we have a bunch of things commented out, a bunch of different examples. We have relative offset, base to user, user to base, forward inverse kinematics, just a bunch of different examples, and whichever one you want to run, you can just uncomment it like so, like I've done with this joint move example. And if you don't want to run it, you can just comment it back and uncomment a different one. But let's start off with this joint move example here. So let's take a look at what this means. So this joint move function, basically what it does here is we just set two waypoints. One is just all the joint angles are 0. One is all the joint angles are 1 in radians. And here we just have a for loop looping through I equals to 0 to 5, and then we're just moving between the two waypoints using the move joint command. So let's go ahead and run this code and see what this looks like. To run this, you just click the start at the top of the screen here. So click start. So the robot is initialized, and as you can see here, the robot is moving between the two waypoints which we have set. And it will do this 5 times as per the for loop. So that's the joint move example. So now let's run a relative offset example. So first, let's comment out this joint move example and go to the relative offset example. Now let's take a look at what this is. So basically in this relative offset, we define the offsets here. So we're not offsetting anything in the orientation. They're just the 1, 0, 0, 0. And here, however, we're offsetting the third position, which is the Z coordinate. So we're just offsetting in 0.1 in the Z direction. And after that, we first call a move joint just to a regular waypoint, which is defined by the target here. And after that, we offset it in the Z direction, which we define here. And finally, we call this exact same waypoint again. However, this coordinate system should have been offset up by 0.1. So this waypoint will be moved as well. So let's save this, and let's run this and see what it looks like. So as you can see here, the robot moves to the first waypoint, and then we offset it up by 0.1, and it will move up, as you can see the robot does. So that's the relative offset example. Let's take a look at another one. Let's first comment this one out. Let's take a look at a forward and inverse kinematics example. So in this example, we first define some joint angles here, joints 1 to 6, and we call forward kinematics to go from these joint angles to the actual the pose of the robot, which contains the orientation as well as the position, and we print it. Now we alter the position of values, the x, y, z, in the pose. Here we just define a random waypoint with just all the joint angles to be 0. And here we calculate for the inverse kinematics, which we go from the pose to the 6 joint angles. So we alter the x, y, z. So now we want to get a new set of joint angles by calling inverse kinematics. We print this new waypoint. And here we just move to this 0 position, and next we move to this new position, which we have calculated based on this inverse kinematics here to get the 6 joint angles. So let's run this and see what this looks like. So here it prints the values, the waypoints, and it moved to the final waypoint after we have calculated it using inverse kinematics. And there we go. Those are just some of the basic examples we have in the C# SDK file. You can go ahead and play around with this more. If you have any more questions, please feel free to contact AUBO support.